Hi guys, welcome to Learn Electronics Repair. So I have something a bit large on the desk. I can't easily show you on the overhead camera at the moment, but I can show you with this one at the side. So this is a speaker system, okay? It's an active speaker system. I'll just show you the other side. So we can see HK Audio, Lucas Nano 600, subwoofer and speakers. You can actually put these speakers onto separate speaker stands, tripods. You can connect them here and here to have them like either side of you, or you can stack them up like this. I'm not sure how many, there's two together there. So that sort of is how it goes. This is used in clubs and bars, microphone inputs, audio inputs, that sort of thing. Probably used for karaoke and stuff like that. Yeah, all the local musicians, most of which is basically karaoke and stuff like that, yeah. At least from what I've heard. Apparently karaoke is not a martial art, but it can be extremely painful at times. So at the moment the pain has gone with this one because the guy who owns it hasn't used it for about a year. It's been in the basement, he says, and now it's stuck in protect mode. I can just show you that. So here are the various controls. This is the on-off switch, and if we just power this up, switch it on, this light goes red, and it should go green after a second or two. It's stuck on red. So this is also, the owner tells me, in protect mode. So that's what's wrong with it. We need to get this to go green. Let's open this up and have a look to see what we have here. Let's see if it's going to be relatively easy to work on or not. I've got the PCBs out of the unit. So this is the mixer panel. Okay. This was held in by 3 bolts from underneath here. Then I had to take the speaker itself out. Once I got the woofer speaker out, I could undo the screws at the other end of here, and I could take this off. And this again was just held in with screws and some brackets in the way I had to loosen. So what we have here then, well, let's see. This is where the mains comes in. So this is your power. There's obviously power getting into it, at least some power, because the protect light is coming on. This will be a switch mode power supply here. So I think these will be your main bulk capacitors. Yeah, they're rated 1000 microfarad, 220 volt each, so that's those. This will be probably the bridge rectifiers, I think we can see there. And then on this side, on the heatsink, there were some devices. So this is the power supply. These are the main switching transistors. This is your transformer. So the other side of here, this is the low voltage side. We should be able to see that from underneath. Yeah, we can see a big gap down here. So this is the high voltage circuitry. This is all the low voltage. And the only thing really going across between the two should be opto isolator, like we have there, and the main switching transformer. Oh, there's another little transformer here, maybe some sort of drive transformer. Unless this has a standby supply, I haven't looked into that. So we have 2 transformers. There's the opto isolator is there. So this is the high voltage side. Then this is the low voltage side. So these down here, these will be your rectifier diodes. This, I would say, yeah, these are the ICs down here, 2 ICs. These are your output devices. This is Class D amplifier. I haven't looked at it, but quite probably 1 amplifier for the bass speaker, 1 amplifier for the tweeters. That would seem the most common type we have anyway. These capacitors are inductors. These will be smoothing capacitors on the secondary side. The same with this inductor. These inductors are part of the Class D amplifier. It looks like there might be another power supply here because we have 2 fairly large capacitors and this transformer. Coming off here then, we can see we've got several wires. So black and red, this is the connections to the bass speaker. That gives us 4 blue and 1 red. And these go up this cable here. So this goes into the mixer section. Now, being an audio mixer, this you would expect to have a plus and minus 15 volt supply, and that might be what 2 of these wires are. So we may well have plus and minus 15 on some of the wires. I don't know which ones. Ground, and the other one drives the horn speaker. So yeah, there's a connector here, so this goes to the horn speaker. But I suspect that you've actually got the drive to the horn speaker on one of these 4 as well, and then the other end of the horn speaker is also ground. So horn speaker output, ground, plus and minus 15. That's what I'd expect to find there. Bear in mind, guys, a lot of this is just supposition at the moment. But we have to have some idea what we're going to expect. Otherwise, how can we diagnose this? We must have some idea, yeah? And that's my best guess at the moment. And we'll find out. The ribbon cable, this is going to have the input audio signals from the mixer, because there's nothing else that comes down to here. So this effectively is the audio input. The protector light LED is probably coming from here as well. You'd imagine the protect circuitry is on here somewhere. Is there anything under here? Yeah, lots of chips. Okay, so that's basically what we have. There's no schematics for this that I can find, or information. So we kind of on our own with this one, and that sort of means that probably we need to start by checking for obvious stuff. The fact it failed after it was in the basement makes me wonder if some sort of humidity's got in at this, but to be quite honest, Gran Canaria is not a very humid place, yeah, so I don't know. I think the first thing I will do is power this up, and let's just see what voltages we have on this, at least power rails, and then we can sort of go from there. So where should I measure some voltages, and where do I apply the power? Well, power's easy on this one, because it's actually marked down here, L in and N in, so this is live and neutral in, so we know where they are. So I've just connected a plug. It doesn't exactly fit right, but it's on there, and I can now apply some power with that. Make sure there's nothing untoward under here. Okay, where do I measure voltages? Well, I have 4 large electrolytics here, and it looks like they're in series. So I've got minus, plus, and then another pair in parallel. So minus, plus and minus together, plus. So the plus and minus together, this should be ground or 0 volts, and this should be a negative supply rail, and that should be a positive supply rail. At least that's how it looks to me. If you look underneath it, you can see all these 4 pins are connecting together. So I'm thinking this is ground, and then we have the 2 outer ones in parallel, as I mentioned, and you can see that the 2 negatives are here. So this should be the negative supply rail, ground and plus. So that's where we should measure the main supply rails. And then the other ones I think will appear on this connector somewhere going to the mixer. I'm not sure where ground is, but I'm pretty sure that ground here will be where these connect together, so we can have a quick look. So I'm thinking that this point will connect to one of the wires on this connector. Yeah, it goes to that one. Yeah, and there's no short there, by the way. Oh, it goes to that one as well. I didn't quite expect that, but obviously I'm not sure how this is wired exactly. This goes to the speaker, this other white connector here. Okay, so on that red one. Yeah, so it looks like we have 2 ground here. I'm not sure if that should be or if it's a short, but let's have a look to see what we've got. So we'll power this up. I'll connect it in series with the light bulb first, and I'll see what voltages I can find. Okay, so light bulbs over there. Yeah, we've got that. We'll power this up, and we know where we're going to check. So let's see what we can see. I've switched the switch is on there, so this should just switch on now. Yeah, that's what I'd expect. Okay, so I think this has got some sort of PFC causing that to go bright again. It didn't blow the fuse before, so I'm going to switch that off and we're going to go again. If there's PFC in the circuit, then it might do that sort of thing anyway. Let's have a look without that switched in. So we're on and the protection light is on. Right, what we got? So this would be ground, this should be some sort of power. 38 volts. This must be minus 38. No. Okay, so straight away we seem to have a voltage rail down. I expect to be something there. I mean, it's a large capacitor, why wouldn't there be something there? That's just dropping down. The power's off now. Oh, I do see a voltage there. Maybe I didn't have a good connection on it. Let me just go again. So power on, protection on, 38 volts. Yeah, minus 38 volts. That was just me. So the low voltage supply, well, we had ground down here. Let's just measure from here to here. I think that was ground. What's this one? Nothing there. Okay. So I need to have a look to see where these are coming from and then figure out that. But it looks like there's no supply down here at the moment. We can go. Power's just off for a moment. Where was the ground? It was this one. Yeah, ground. Ground. So we can go from ground to here. That's the 2 volts. Let's switch it on. Still no supply there. Okay. Let's have a look to see where this lot goes to. I've turned the board over. I've put it on top of a book. I don't like putting high voltage boards directly on my anti-static mat. To be fairness, it's never caused a problem because sometimes I have done it, but just call it force of habit if you like. So looking at these wires here, and this lot, do you know, I'm not thinking this is what I thought it was now, because I can see that these wires here go down to there. There's another connector under here, and this is almost certainly connecting to these 2 outputs here for if you want to put the speakers separately on cables or drive 2 more speakers. So I'm thinking now that this actually has nothing to do with the supply voltage to this board at all. I'll just check them, but that's now, you know, guys, I look at this stuff and then sometimes I just change my mind. Also, these wires are all down here somewhere around these outputs, so I think my second intuition is the better one. Another good reason, well, the mixer unit isn't going to draw much power, so I have such thick wires, yeah. So let's just check this if we can. Go to continuity. Okay, so 2 of these red ground. That's one of them. And that's also ground, so the heatsink is ground. So if we measure the voltage on here now, I'm thinking the red and black, we know that's the base speaker. We know where they go. I've got 4 more wires and 2 appear to be ground. So I suspect what we've got is we've got ground and positive going to each speaker of the 2 speakers. So I'm thinking there probably shouldn't be any voltage on these. Now, protection mode generally means that there's a DC voltage offset on one of the outputs of the speakers. That's the whole point of protection mode. It stops the DC voltage appearing across the speaker. Let's have a look to see if we can see any voltage across any of these. And if we can't, then we can say for certain the power for this and whatever's lighting this LED comes up this ribbon cable, okay? So we'll switch it on. We'll have a quick look. Yeah, protection lights on. So what do we have? Minus 0.012 volts. Naught. Minus 0.015 volts. Naught. Minus 0.01 volts. And naught, I guess, 0.04. 0.004. So, A, these are not voltage supplies, I would say. B, there's no DC offset on them, so there isn't some fault causing DC on the output, which is what you could worry about with a protection mode. But there's no relays on this either. Quite often an amplifier has relays on the output to disconnect the speakers. And the other thing we can say we know is the power gets to here somewhere else. So there's a couple of capacitors down there that again appear to be wired kind of like probably the positive and negative connected together, 2 voltage rails. I also have 2 here as well that could be on that sort of power rail. Let's have a look. Yeah, so 2 outputs from here go to there, and these 2 are connected together. Let's have a look what we have. These, yeah, they're connected together. You can hear it. Let me just put the meter away, you can see it. Okay, so these 2 connect together. Do they connect to that heatsink, which we know is ground? Yes, they do. So it looks like we've probably got 2 voltage rails here. And these 2, well, I'm not sure exactly what they're doing, but I wouldn't be surprised if they're also some sort of voltage rail as well. Let's have a look on these to see what we have, and then we'll flick it upside down, power it back up, and we'll have a look at those as well. What I'm looking for is probably a plus and minus 15 volt supply to the mixer unit, okay? Just so I've got a hand free, I'm going to clip a crocodile clip onto this heatsink. That's my 0 volts, my black meter lead. So we're going to say that here, yeah, what we got on it? Can you see? Try and keep my hands out of the way. What we got? Minus 15, and this one plus 15. So that's what I was looking for, and I've got that. We know these 2 are plus and minus, was it 35 or whatever it was, that's his main supply to your speakers. What are those 2? These were in parallel, so 2 voltage rails. I think this is probably another voltage rail. I've switched it off, so let's have a look and we see what's on there as well. As you can see, when you're faced with something like this, you've got to start somewhere. So, because no fuses were blowing, I decided in this instance to power it up and see what I can see. At least can I identify all the voltage rails and are they present and what I expect them to be. Now, I have 2 capacitors here. I'm pretty sure this area is ground. I have 2 more capacitors here as well. And this area, we can say this is ground. I'll just put the meter onto continuity. I have the black lead clipped to the heatsink. Yeah, this is ground. I'm hoping by now you'll start to recognise what is going to be ground anyway. But it's always worth checking because sometimes you're wrong. So these are the two capacitors. So we have two voltages here. And I don't know what they're going to be. I just want to see if they're like sensible, if you get the meaning of that. So once again, power up. Protection lights on. You can't see it, but it is. Voltage. That's a plus 17.6. And that's at a minus. It's the same. So we have a plus and a minus 17.6. Say 18. Plus and minus 18. Sounds sensible. This one is a 15. And a minus 15 again. So all those voltage rails to me seem reasonable. I don't know what they all do because I don't have a schematic. I'm not familiar. I've never seen one of these before. But they all seem correct. I don't see anything there that makes me think, I've got a problem here somewhere. So where do we go next? Well, personally, I think the next thing to do is have a look at the output devices in which we have integrated circuits here, not separate MOSFETs. I want to look at these output devices to see what they are and see if I can find a data sheet. And then have a look to see what these do, what conditions should be around them, what voltages, and then see if they all look correct. Of course, before I turn this over, I want to make sure there's no high voltage in this thing. So let's have a quick look again. Directly across these capacitors, 2.5 volts, 1.7 volts. Okay. The fact those drop away as well tells me this thing is basically running. Okay, let's look at these output devices. Well, here they are on this heatsink. Just move that out of the way. Yeah, you can see them there. Obviously, I can't see what they are with these clamps bolted on them, so I'm going to take these clamps off. I strongly expect they're both going to be identical, but let's be sure before any stupidity starts to happen, yeah. And then hopefully we'll have a better idea about this thing. Because right now, well, you know what I can see, but there's plenty I can't see. Okay, I've removed the little metal brackets. So we can see what we have. They are both identical. TDA 8954J. So let's have a look at the datasheet for those. While I'm here, I just spotted another pair of capacitors here. This is quite possibly another set of voltage rails. They don't look like they may be wired in series like the other ones. They're kind of like a different way round, one of them to the other. Let's have a look. So they're here. So one's wired across there and then the other one's that way. But I think this and this are probably ground. Okay. So this one and this one. Yeah, they are ground. So we have, again, and they're not connected to each other. Looks like we have another pair of voltage rails here. If this one and this one is a plus and one is a minus on the capacitor, let's have a look. So this end, this is the positive of this one. And that goes to, oh, that looks like it goes to the positive of this one as well. So I don't think this is symmetrical voltage rail. But I can measure the voltage and then we'll see what we do have. So this is one of them here. Okay, what have we got? Plus 38, and the other one minus 38. Is that the same as these? Yes, it's basically the same. So those appear to be the same as those. Are they connected to them? Well, let's see if there's any voltage still in. I've switched the power off. Yeah, some voltage in there, but it's going. So something's drawing power from that, even though there's no audio signal coming in, but it's not drawing huge amounts. It's taking a little while to discharge. But if those two are connected to these two, then any voltage residual shouldn't affect the reading because they're connected to each other. Yeah, so let's have a look. So this rail, does that go to one of these two? Let's see. Yes, and that one's reading like a voltage, so that goes to there and that goes to there. And then we know ground goes to ground. So those two capacitors, whatever they are powering, are in parallel with these two pairs of capacitors. It's the same voltage rail. Well, sensible or not, that doesn't ring any alarm bells with me. So I hope you think I'm following this in a kind of a methodical way. This is how I tend to work, and hopefully how you might want to learn to work. So let's go back to those output devices. We've got the port number. Let's see what they are and see if we can figure out anything about protection mode. I mean, maybe the protection mode is driven by these. I don't know. There's more circuitry up here, but well, we've got to go to somewhere next. So let's look at the data sheets. And here's the data sheet. I've had a look through this because there's quite a bit to read on this one. So you can look at this yourself, but I'll give you the most important parts of it. So basically these amplifiers, they're 2 times 210 watts. So they're stereo amplifiers. They can either be used single-ended, so 2 stereo channels, or they can be used in a bridge mode so that you have twice the power, 420 watt for subwoofers. Okay, this is the pin out. This is the type. We have the single-sided ones. Pin description, and the ones we're really interested in are these pins: Diag 1, Diagnostic 1, and Diag 2. Okay, Prot or protect this as a decoupling capacitor. So there's a capacitor connected to this for overcurrent protection. This is temperature fold back. It's kind of a temperature protection. It basically means the amplifier will turn the power down to try to reduce the temperature before it shuts down. Okay. So it tells us something about this chip, and if we just look down, diagnostics. So it's telling us about these 2 diagnostic pins. It basically says that they are open drain. So normally you'll have a pull-up resistor on these up to 5 volts. Can be used as the pull-up voltage level, and if the MOSFET turns on, it pulls the pin down to signal there is a problem. Okay, goes on the frequency. These run at 250 kilohertz to 450 kilohertz. These are type class D amplifiers, and this is the various protection methods. So it explains them here. But it basically tells us, if we scroll down without me going through all of this with you, again, you're welcome to have a look, that pin Diag 2 used to monitor over current status, over current protection, a pulse signal at the switching frequency generated on Diag 2 and current limiting is enabled, and to monitor the protection status. Okay, it goes again, pulse signal with a minimum width of typically 100 milliseconds on Diag 2 to indicate the amplifier has been switched off by one of the protection circuits. There's a table of these, this table 5. It also says this signal is generated at startup before the amplifier output starts switching. Now, the guy told me that red protect lights come on for a second or so, then go off. And that's what's not happening. This is an example of it. You see the pulses we get on here. And we have various other protection modes which we can look at if we need to. But I'm interested in this lot basically. So it's saying for all these various problems, pin Diag 2 is active only for the temperature. Fold back as pin diag 1 active. I say this effectively the amplifier is still running, but it reduces the gain and monitors the temperature to see if it reduces the temperature. If the temperature still doesn't reduce, then we get an over temperature protection, and diag 2 is active. Okay, and I'm pretty confident this is our problem, mainly because the thing isn't even powering up, so I can't see how something is overheating just yet. Okay, so what I want to do is have a look to see what's happening on this pin V diag 2. I'll have to use my oscilloscope because they're pulses, it's not a logic level. And let's see if we can see why this is behaving the way it is. So we can see the pin diag 2 is on pin 6. Diag 1 is on pin 4, but it's pin 6 that I'm really interested in. Let's get the oscilloscope and see what it's doing. I'm just going to tag a stiff bit of wire onto both the pin 6s. It's easier to probe without the scope probe falling off. I have my hands free. I've just noticed we've got some rather dubious looking soldering on this one. Maybe this is part of the problem for all I know. So I'll just sort this out. Okay, so this is pin 1 with a little square thing. 1, 2, 3, 4, 5. This is pin 6. I'm just going to use, it's just a 22 ohm resistor, but I'm not using this as a resistor. I just want to find something stiff to tag on here, and this should do just fine. Yeah, so it's just fastened on there. I can clip my scope probe to the wire low down here, not to the side of the resistor. Doesn't look very good, that actually. I'll just redo it with a bit of extra fresh solder. This is, of course, is when you should just leave it well alone. But I always seem to fall into this particular trap zone. Try that again. Okay. And the same with the other amplifier. Just look at the connections around this one. These look much better actually. So pin 6 is here. Again, I'll find another resistor. Looks a bit different, but it'll do the job. Okay. Yeah, that's well enough attached. Again, not quite brilliant. Let's just go again at it. Well, I don't think it's going to fall off. That's the main thing. Okay. So let's attach our scope probe and let's see what we can see. So according to the data sheet, these pins should be high, which means there's no error, or pulsing low if there is an error. But when you first switch on, obviously the low till it powers up, which is why the protect light comes on initially. So that's what should happen. I've got the scope set to 2 volts per division. I'm on the right one. Yeah, I can just disturb a bit with my finger, so I'm definitely on the right lead. Because sillier things than that have happened. So let's switch this on and see what happens. Well, it kind of like went up very slightly and down, so that's low. So that shouldn't be low. That means there is some sort of protect error, or something else is wrong, like the pull-up circuit isn't working for some reason, maybe. Go to this one. So this is the other one. Switch on. Same thing happens. Well, according to the datasheet, the pull-up signal should be 5 volts or less, and so far I haven't found any voltage rails on here that have anything like that. So I wonder if it means we've got a voltage rail missing somewhere.